Study Section 2, Presentation of Data. Introduction. In the last study session, we defined statistics. The three domains are organizing, summarizing, and presentation of data. Data must be reduced to manageable proportions as well as highlight essential facts. Data may be presented in the form of diagrams, tables, graphs, or frequency distributions. In this study session, you will be introduced to how to make tables, charts, and diagrams for observed data. Learning outcomes for study section 2. At the end of this study session, you should be able to construct a frequency table, classify data by grouping, draw a histogram. Presentation of data. Data presentation is the method by which people summarize, organize, and communicate information using a variety of tools such as diagrams, distribution charts, histograms, and graphs. The presentation of data in the form of tables, graphs, and charts is an important part of the process of data analysis and report writing. Although results can be expressed within the text of a report, data are usually more digestible if they are presented in the form of a table or graphical display. Graphs and charts can quickly convey to the reader the essential points or trends in the data. Graphs and charts are particularly useful when data are being presented to an audience because information has to be conveyed in a limited time period. Methods of data presentation. The following are standard methods of presenting qualitative or categorical data. Frequency table. The frequency table is a tabular arrangement of data by classes and to determine the number of times the variable belonging to each class occurs. Example 2.1. The length of 15 trees are recorded to the nearest centimeter below. What can you say about this? Does it reveal anything interesting to you? Despite the fact that we have 15 observations, this data comprise only 4 different numerical values. Every value is equal to 1, 2, 3, or 4. Hence, the data is reduced without any loss of information as given in Table 2.1. Table 2.1, Frequency distribution for lengths of 15 trees. In example 2.1, the numerical value 2 appears 6 times, which is 40% of the total number of observations, 15. If, however, the 2 had appeared 6 times in 150 observations, this would amount to 4% of the observations. Sometimes, the frequency with which a particular value is observed is less revealing than its relative frequency, that is, the frequency divided by the number of observations. Therefore, relative frequency distribution is a representation of data in which every observed value is paired with its relative frequency, that is, f over n, where f is the frequency and n is the number of observations. Can you try it for Table 2.1? Great! Compare your result. Table 2.2, Relative frequency for length of 15 trees. Other useful presentations of data are the cumulative frequency distribution and the cumulative relative frequency distribution. The cumulative frequency of a value is its frequency plus the frequency of all smaller values, and similarly for the relative frequency distribution as shown in Table 2.3. Table 2.3, Cumulative frequency distribution and relative frequency distribution for lengths of 15 trees. Do you notice any striking feature of the last value? It is apparent that the largest value, that is 4, has the total number of observations, and for the cumulative relative frequency, it is always equal to 1 or 100%. There should be 100% in all. We got 99%. What happened? The arithmetic is right, but when we rounded the fractions up to 2 decimal places, a little precision was lost. Such round-up errors will be with us as we do more arithmetic. Tabular representation of group data. What happens when we have large masses of raw data and you want an overall picture at a glance. In example 2.1, only 4 numbers could be observed. In some experiments, the number of values to observe may be so large that even the frequency distribution discussed above become unwieldy. Alternatively, the width or size of class interval is obtained by dividing the range by the number of classes 8. If, for example, the range is 84 minus 11 is equal to 73, then 73 divided by 8 gives 9.13, so the class width can be 10. C. Class boundaries. Class boundaries are also known as true class limits. Theoretically, this includes all measurement from less than 0.5 of the lower class limit and plus 0.5 of the upper class limit. What are the class boundaries of 40 to 44? They are 39.5 to 44.5, where 39.5 is the lower class boundary and 44.5 is the upper class boundary. In practice, the class boundaries are obtained by adding the upper limit of one class interval to the lower limit of the next higher class interval and dividing by 2. D. Class size. It is also known as class width or strength. It is the difference between the lower and upper class boundaries, and it is commonly denoted as C or W. So the class size for interval 40 to 44 is 44.5 to 39.5 is equal to 5. E. Class mark. It is the midpoint of the class interval. It is obtained by adding the lower and upper class limits and dividing by 2. Thus, the class mark of the interval 40 to 44 is 40 plus 44 is equal to 42. Presentation of frequency distribution in form of charts. A chart, also called a graph, is a graphical representation of data in which the data is represented by symbols such as bars in a bar chart, lines in a line chart, or slices in a pie chart. A chart can represent tabular numeric data, functions, or some kinds of qualitative structure and provides different info. Histogram. This is a presentation of frequency distribution in form of a diagram consisting of rectangles whose bases correspond to class boundaries on the horizontal axis, and the height or length of the rectangles are proportional to the class frequency. The centers are the class mark. Area of each rectangle is proportional to the frequency of the class. If the class intervals are equal and the class limits are not overlapping, all we need to do is to adjust the class limit to class boundaries known as true mathematical limits. Area of rectangle is equal to common class width times height of rectangle. A histogram is constructed by plotting the class boundaries against the corresponding frequencies. Example: the length of 30 cassava plant leaves were measured and the information was grouped as shown. Measurements were taken correct to the nearest centimeter. Draw a histogram to illustrate the information. Solution: histogram showing the length of 30 leaves. Frequency against length of leaves. Standard deviation is equal to 0.94, mean is equal to 2.8, n is equal to 30. Polygon and curve. The frequency polygon or polygon graph is a graph for the frequency distribution by connecting the midpoints of the tops in the histogram. In other words, it is the plot of the class mark or midpoint against the corresponding frequency for a distribution of equal interval when the points are joined with ruler. It is referred to as frequency polygon, but the smoothing of the frequency polygon freehand is called the frequency curve. It is of interest that the shape of the graph seems to indicate whether the sample was drawn from a population that is normally distributed. Example: the data below are the income distribution of employees of a finance house. Use the data to construct a frequency polygon. Solution: we need to convert the class limit to class boundaries to construct a histogram. Frequency polygon of annual salaries of employees. Cumulative frequency curve or GIF. and polygon. When you plot cumulative frequencies against their corresponding class boundaries, you will obtain what is known as cumulative frequency curve or ogive. This can be of less than or greater than. The joining of the points with a ruler resulting into sharp edges is called cumulative frequency polygon. A. Less than cumulative frequency distribution. The cumulative frequency is calculated by adding successive frequencies together from top to bottom and plotted against upper class boundary. The last cumulative frequency must be equal to the total frequency of the given distribution. Example: the distances traveled during the year by marketing officers during 2006 were as follows. Solution: B. Greater, more than cumulative frequency distribution. The cumulative frequency is calculated by adding successive frequencies together from bottom to top and plotted against lower class boundary. The first cumulative frequency must be equal to the total frequency of the given distribution. Example: using the same data of distances traveled above, we have bar chart. It is the diagrammatic presentation of data through the use of rectangular bars consisting of separated vertical or horizontal bars with equal width. It can be used for comparison. There are different types of bar chart. These are 1. Simple bar chart. It is the presentation of non-numeric frequency and the corresponding variable, usually a single variable, in vertical or horizontal bars. It enhances the comparison of a single magnitude. Example: income for Wale Associate Bank in 2006 is as follows. Construct a simple bar chart. Simple bar chart showing income for Wale Associate Bank. Simple bar chart showing income for Wale Associate Bank using vertical bar chart. Merit of a simple bar chart. 1. It is very easy to construct and understand. 2. Variable values can be easily compared. 3. Totals can be easily defined. Disadvantage: it cannot be used to represent more than one variable. 2. Multiple bar chart. It is sometimes referred to as compound bar chart. It allows the use of more bars for visual comparison. It involves grouping together of 2 or more charts for adequate and effective comparison of variables. Example: the table below shows the grade of students in the Department of Sociology from 2004 to 2006. Multiple bar chart showing students' grade. The chart shows the grade of students in the Department of Sociology from 2004 to 2006. Advantage of multiple bar charts: more than one set of comparison is possible. Disadvantage: the diagram may be untidy and clumsy if it contains too many information. 3. Component bar chart. It is a form of the simple bar chart in which the bars are subdivided into component parts. Example: construct a multiple bar chart for the previous example on multiple bar charts. Advantages of component bar charts. 1. It can be used to represent more variables because it occupies less space through subdivision of bars to denote variables. 2. It allows comparison to be made with each component. Disadvantages: 1. The diagram may be too clumsy if it contains too many information. 2. It is not easy to construct. 3. Comparison across bars is not possible. Pie chart. It can be defined as a circle divided into sectors. The circle represents the total of the data being presented and each section is drawn proportional to its relative size. It shows relative changes, but its construction is time-consuming. Example: construct a pie chart for the table above. Solution: pie chart. Pie chart showing department and number of students. Summary of study section 2. In this study session, you have learned that 1. The presentation of data in the form of tables, graphs, and charts is an important part of the process of data analysis and report writing. 2. Graphs and charts can quickly convey to the reader the essential points or trends in the data. 3. The frequency table is a tabular arrangement of data by classes and to determine the number of times the variable belonging to each class occurs. 4. Grouping is a matter of common sense, but efforts should be made to have a reasonable frequency distribution of the data. 5. The frequency polygon or polygon graph is a graph for the frequency distribution by connecting the midpoints of the tops in the histogram. This is the end of study section 2. Thanks for listening.